Hello everyone. In this video, we will learn load factor and performance analysis in hashing. Load factor is a very important concept because it directly affects how fast or slow hashing works. We will understand the concept, see examples, and study how it affects search, insertion, and deletion. Let us first understand what load factor means. Load factor tells us how full the hash table is. It helps us to understand whether the hash table has enough space or is overloaded. If the load factor is high, collisions increase. If the load factor is low, hashing works very efficiently. The load factor is represented using the symbol alpha. It is defined as alpha equals n divided by m. Here, n is the number of keys stored in the hash table, and m is the total number of slots in the hash table. This formula helps us measure how much the table is filled. Let us take a simple example. Suppose the hash table size is 10, and the number of keys stored is 5. So load factor alpha is 5 divided by 10, which is 0.5. This means the table is 50% filled. This is a good situation because there is enough free space. Now let us take another example. Suppose number of keys is 15 and table size is 10. So alpha becomes 15 divided by 10, which is 1.5. This means more keys than table slots. This situation is possible in chaining. Because in chaining, more than one element can be stored at the same index using a linked list. Load factor directly affects the performance of a hash table. As load factor increases, collisions also increase. More collisions mean more time for search, insertion, and deletion. So controlling the load factor is very important for good performance. When the load factor is less than 0.5, the hash table is sparsely filled. There are very few collisions. Most operations like search and insertion are very fast. This is the ideal condition for hashing. Let us see an example. Suppose table size is 20 and number of keys is 8. So alpha is 0.4. Because the table has many empty slots. Most searches will require only one comparison. So performance is very good. When the load factor is greater than 0.7, the hash table becomes heavily loaded. More and more collisions occur. This leads to long probing sequences in open addressing or long linked lists in chaining. For example, if table size is 10 and keys stored are 9, alpha becomes 0.9. In this case, most insertions and searches will require multiple probes or comparisons. So performance becomes slow. Now let us see how load factor affects search operation. When alpha is low, there are fewer collisions and search time is approximately 0.1. When alpha is high, we may have long chains or many probes, and search time increases and may reach 0.n in worst case. For example, if alpha is 0.3, the key is usually found in one step. But if alpha is 0.9, we may need several comparisons before finding the key. So higher load factor means slower search. Let us now discuss insertion. When alpha is low, insertion is very easy because empty slots are available. Collisions are rare. When alpha is high, collisions occur frequently, and we need more probing or longer linked lists. At alpha equal to 0.2, Insertion happens almost immediately, but at alpha equal to 0.8. Insertion may require several probe attempts before finding an empty slot. Deletion is also affected by load factor. When alpha is low, deletion is simple and requires minimal changes. When alpha is high, deletion becomes complex. In open addressing, we may need rehashing or special marking to maintain correctness. With a good hash function and controlled load factor, hashing provides constant time performance. As load factor increases, collision probability also increases. To maintain efficiency, hash tables are usually resized and rehashed. When load factor exceeds a threshold like 0.7, let us summarize the performance. Search operation. Average case is O1, worst case is ON. Insertion operation. Average case is O1, worst case is ON. Deletion operation. Average case is O1, worst case is ON. So hashing is very fast when load factor is properly controlled.
Thank you for watching. Don't forget to share and subscribe. It really helps the channel grow and keeps you updated with new content. Your support means a lot. Thanks again.